Dear students, today we are going to study about curve fitting. Curve fitting. What is curve fitting? Curve fitting refers to finding an appropriate mathematical model. That is, we are going to find an equation that expresses the relationship between dependent variable y and a single independent variable x. Simply, we are going to find an equation in terms of x and y and estimating the values of its parameter using nonlinear regression. Types of curve fitting. There are two types of curve fitting. One is method of least square, another one is interpolation. So today we are going to study about method of least square and we are going to study about interpolation in our next class. Method of least square. So first, what is method of least square? For given data of discrete values, derive a single curve that represent the general trend of the data. That means, see the example here. Here the dotted points. The dotted point refers given data. The straight line very closer to dotted points refers best fit by method of least square. The line is closer to all the points, but it never touches here, never passes through here. So this is method of least square. Whereas in interpolation, see here, given data for discrete values, fit a curve or a series of curves that passes directly through each of the points. That is, see the dotted points here, that is given data. So here there is a curve that passes through all the dotted points. That is interpolation. If the fitted curve passes through all the points, that is interpolation. If it is very closer to all the points, that is best fit. That is method of least square. Right now, method of least squares. We are going to study about method of least squares. So procedure for fitting straight lines. So this is an example procedure for method of least square. So here we are going to fit a straight line. See here, fitting a straight line to a set of paired observations x1, y1, x2, y2, xn, yn. So here x values are x1, x2 up to xn. Y values are y1, y2 up to yn. So here number of data is n, 1, 2, 3, likewise n. So here the mathematical expression we are going to fit is this straight line equation y equal to a naught plus a1x, a straight line. So here a naught is the intercept and a1 is a slope. So for this, so here is the first step, here is the standard procedure, define ei. Ei refers error between actual value and the approximated value, right? So actual value here is yi minus model equation, replace x by xi. Right now, criteria for best fit is minimum of SR equal to minimum of A naught A1 summation E square EI square. So this is method of least square. So here we square the errors and we apply maximum minimum conditions to find the values of A naught A1. So here EI equal to yi minus A naught A1 is substitute here, we get an objective function here, right? So here the objective function is minimum of a naught a1 I running from 1 to n, that means n datas. The equation here is yi minus a naught minus a1 xi, just like this, and square. Now so continue here. Now differentiate partially with respect to a naught, we get this equation, right? Put this is equal to 0. To find the maxima minima, we put first derivative equal to 0. So differentiate with respect to a naught and put equal to 0. Now simplify this expression. Here, see here, taking summation inside the equation become I running from 1 to n yi minus I running from 1 to n a naught minus I running from 1 to n a1 xn equal to 0. Summation is only for xi and yi, because both are variables, not for constant a0 and a1. Okay, a0 and a1. So a0, a1 are constant, they are independent to summation. So we can write like this: summation I running 1 to y is here. This become n, because we are adding n values, right? N a0. So this become a1 is constant. Bring this is outside, right? So this is one of the normal equation. Similarly, differentiate the equation. Differentiate this equation with respect to a1. We get this equation, put equal to 0. Similarly, simplify this, we get second normal equations. So here in our model we have two unknown variables a0 and a1. Using this procedure we get two equation, two normal equations. Solving this normal equation we can easily find a0, a1, right? Then we can easily fit the curve. Steps for curve fitting. So these are the standard procedure steps for method of least square. Choose the model to be fit for the given data. Once the data is given, we have to choose the appropriate model. So here the model is y equal to a plus bx. So here x and y are variable, a and b are constants. Identify the unknown values. So the unknown values are a and b. So we are going to find normal equation to find a and b. That means find normal equations for a and b. Then solve the normal equations and find the values of a and b, and we can easily fit the